Hey guys, I'm Shreyas and today we're in the 17th day of the July LeetCoding challenge, and the question for today is 3 equal parts. So they're given us an array of zeros and ones, and we have to determine if we can partition the array into 3 parts such that the binary values of all the 3 parts are the same. So that's the question, and if we can partition it, we have to return the value of I and j, where I is the index of the last element of the first subarray and j is the index of the first element of the last subarray. So, so in this example, we have the first subarray is only 1, the second subarray is 0 and 1, and the third subarray is also 0 and 1. So all of them have a value of binary value of 1. So hence return 0, 3. So that's the question. And so since the constant is like 10 power 4, we have to look for an O of n solution or O of n log n solution in this problem. So basically this problem is based on some observations and some conclusions based on that observation. So, and followed by some simple implementation of the conclusions. So the observation is that, okay, yeah. So the observation is that suppose we have a binary number. Suppose we have 10 is represented as 0101 in binary, right? So this is the binary number we have, and let's call it A. And then suppose we have to get another number B with the same value, then it has to be the same, right? Like it has to have the ones at the same positions what 10 had, only then we can get 10 back. So there's no other combination of ones and zeros which will get us 10, right? So the resulting number B also should have ones at the same positions, only then we get the same value. So that is the observation over here, that if two binary numbers should have same value, then the set bits should be at the same positions, ones should be at the same positions. So that is the observation, and the conclusions based on this observation is, so first of all, I'll just erase 1 second. Let's take some random array of zeros and ones. So this is the array of zeros and ones, and if you want to, so there are some certain like 3 to 4 rules we have to follow based on the observation only. So the first thing is that the last subarray might have some trailing zeros, and trailing zeros will contribute to the answer, while leading zeros don't contribute to the answer. So we need to count the number of zeros what the last subarray has, and the first and the second part also should have those many number of trailing zeros only, as they contribute to the answer. So over here the third subarray has one trailing zero, so the first and the second should also have the same number of trailing zeros. Suppose we take the third part to be this one, it has a value of 6, binary value of 6. So we need to ensure that the first and the second part also should have the same value. So the only possible answer for the first subarray is this thing, which also has a value of 6, and now we have to choose the middle part. So one possibility is this thing, which also has a 6 value, but there are some zeros left out which are not there in any parts. So since they are leading zeros, since this thing is a leading zero for second part, so we can just include in the second subarray only, as they don't contribute to the answer. So we have included this in the second subarray, and these two zeros we can include them as leading zeros for the third subarray. So now all the subarrays have a value of 6. Yeah. So that's the observation number 2. So if they have to have the same value, then they have to have the same number of ones. So over here all the subarrays, they have the same number of ones and the same number of trailing zeros. And the last observation is, our last conclusion is that the ones should be at the same positions as we discussed before. So over here, if we exclude the leading bits and separately write the subarrays, then they will have the ones at the same positions. For example, this was the first subarray, and this was the second, and the third one was 2 leading zeros and 1 1 0. So they had ones at the same positions, and they had the same number of trailing zeros. So this is the condition that we have to check for in the problem. So the implementation is quite straightforward. So first we just find the number of ones using the count function, and if it's not a multiple of 3, then we can't divide it into 3 equal parts, so just return is not possible. And if it's equal to 0, then we can return any possible index. So I've just written 0 comma n minus 1, it could be anything. And first we are finding the number of trailing zeros from the back. So these are the number of trailing zeros that the third subarray will be having. And now comes the main part. So since we have to divide the array into 3 partitions, we have to split it twice, right? Only then it becomes into 3 parts. So that's why this for loop is running twice. And then for the first time it's forming the first subarray, and for the second time it will be forming the second part. His subarray and part are both the same. Yeah. So first time it's forming the first subarray, and so start is 0 in that. So it's starting from the current, like from the beginning of the array, and the first subarray should have this many number of ones and this many number of trailing zeros. So that is the target, to form a subarray with this many number of ones and this many number of trailing zeros. And location 1 and location 2 is the I comma j that will be returning after at the end of the function. So in the split array function, we'll just iterate till that position where the subarray consists of this many number of ones, and then after it consists of this many number of ones, we'll have to check if it consists of if there are this many number of trailing zeros after the last one. So for the ones we are checking in this function, and for the trailing zeros we are checking in this while loop. So these are just simple implementations which will iterate through the end if the condition is satisfied, or else it will return -1 in the middle. So if we have this many number of ones and trailing zeros, then we return the last pointer, the index to the index of the last element of the subarray. So this thing we execute twice, and so after this, and if we are able to, if the condition is satisfied for both the times, then we are able to, then we have 2 of the 3 conclusions satisfied. The 2 conclusions are it has same number of ones and same number of trailing zeros. Now the third conclusion it has to satisfy is that the ones should be at the same positions. So the ones should be at the same positions. So for example over here, yeah, so for that what we'll do is we'll just keep the starting, we'll just take 3 pointers which are pointing to the starting index of the 3 subarrays, and then it's just brute forcing, just iterate through the end of the subarray, and for each index check if the values of corresponding values at that index for all the subarrays is the same or not. So it's just a simple while loop where we check the equality of the elements, and then we just return at the end we return the I comma j if at all positions the subarrays have the same value. So the time complexity for this approach is O of n, and because we are just iterating only once through the array, and the space complexity is constant, that's O of 1, as we are not using any extra space. And so yeah, that's it for the video guys. Thanks for watching.